So let me quickly try to draw it first, so that we have, it won't be perfect because already I sent the picture, right? So it won't be as perfect as that one. So this is P, this is Q, which is, we have 90 degrees there. We have A, and then we're told that this side is equal to that one. And we're told that this one is parallel to that one, right? Then we have S, and then we have RD. And then we are asked to prove that AQ is equal to AS, right?
Yes.
AQ is equal to AQ being
AF.
this one is equal to AS being this one. So I told you that in this kind of problems, you don't have to stress yourself. Already they gave you a hint, right? Yes, we can see that we are going to be dealing with these two triangles, right? And we can already see parallel lines. And every time we see parallel lines, I can already see alternating, right? We have a Z here. Can you all see it? Can you all, it's not clean as the Z you want to see. It's just straight, it's like this. But still, if you're told that this is parallel to this should be equal to that. Do you all agree?
Yeah.
Yes.
Yes.
Now, because they are saying AQ, and AQ is that one, and AS is this one, that is how I know that we're going to be dealing with these two triangles. They can't give you these two things and then you deal with one triangle. Every time you talk about congruency, it must be two triangles. You can't talk about congruency and you compare one triangle. It's impossible, right? And what I said is that always you try to label your triangles starting with the common side, right? If it doesn't work, you start with the hint they give you. So the common side is AR, but already they gave us a hint to say prove AQ and AS, right? So we are going to basically say that we are going to have triangle AQ. If I take AQ, what will I be left with? Because it's going to be AQ and R. Do you agree?
Yes.
Okay. So we have triangle AQR and triangle AS. If I take AS, I'll be left with R, right? So we have these two triangles. That's our focus, right? So already I'm seeing something. I'm seeing that we have first and last, which is AR, first and last, which is AR. So I'm going to say AR is equal to AR. What is the reason? Come on.
Common side.
Yeah, come
Common
on.
side. Sir.
Yes. Come on, come on. So from there, what else do we have? I just told you something that is important now. I gave you the answer before we even started. Come on, good people. Parallel lines.
Parallel lines. PQ is equals to AR because of alternating angles.
PQ?
Is equals to AR.
PQ is a side. PQ is a side. We just want the angle.
Yeah. Oh.
Yeah. If you say PQ, you are referring to the side. And always when you talk about alternating and all those other ones corresponding and cointerior, we are focused on the angles, not the sides. So you must say side P, not side, angle PQA, which is this one here. Do you all agree? P angle QA is equal to Q angle AR. Does it make sense? It doesn't.
No.
Imagine if they told you that this was Q1, Q2, and this was A1 and A2. we were basically going to say that Q1 is equal to A1.
Yes.
And the reason would be alternating angles. But this time around, they didn't give us that this one is 1, and this one is 2, and this one is 1, and this one is 2. Hence, we can't come here and write Q1 and Q2 because they didn't give us that. So what we're basically saying is that when we say P, Q, angle A, we are saying you start from P. Always the one that is in the middle is the angle we focus on. So we have P, we have Q, but we can see that Q is going that way, coming to R, right? But that is not what we want. We want this angle, not the whole of it. So that is why we are saying P, angle Q, A. So we are directing you that you move this way, not that way. Does it make sense?
Yes.
So if I was like to say Q is equals to A, would I be wrong?
Very wrong, because
Okay, sir.
Q is the whole of this angle. You see,
Okay,
we have
sir.
P, we have Q.
Yes.
Q is the whole of this angle. So it wouldn't make sense to the person who would be marking your paper. Like, how is the whole of this angle equal to this one? So that is why we are being specific to say P angle QA, right? It's that one.
Yes.
It's equal to Q angle AR. Q angle AR. You turn here. Because if you just say angle A, the whole of this is angle A, right? So you're basically saying that this is equal to 180 degrees, which doesn't make sense. Do you understand?
Yes, sir.
I'm happy. Now, we all agree that this is equal to this, which is going to be 90 degrees. How do we know it's 90 degrees? We were given that that one is 90 degrees. Every time you see that thingy, it's 90, right? So reason we said is what? Alternating angles. And every time you state alternating angles, you must say which lines are parallel. So we have PQ parallel to, PQ is parallel to AR, right?
AR.
PQ parallel to AR. Remember, parallel lines are the ones that we never touch. So, and we are given PQ parallel to AR. Does it make sense? Yeah. So far, we have 2 statements. How many statements do we need for congruency?
3.
3. So we have proved 90 degrees, and the only reasons amongst all the reasons of the congruence that deals with 90 degrees is the right hypotenuse side. So every time you see 90 degrees and you prove it in one of your statements, you already know that the reason for your congruence is going to be right hypotenuse side. And we know that the hypotenuse side is the side that is opposite 90 degrees, right? So our hypotenuse, if this is 90, do you agree that this will also be 90?
Yes.
Because it's angles on a straight line and they should add up to 180. Are you all happy? You don't have to prove that on your statement. It's given. If this is 90 and they're on a straight line, this has also to be 90 because 90 and 90 give us 180. So it means our hypotenuse for this triangle is this side. For that triangle is that side, which is QR and RS, right? So that when we come here is second and last. QR is equal to RS, right? Do you agree? So we have QR is equal to SR or RS. And the reason for that, that was given. We were told from the get-go that QR is equal to RS. Does it make sense?
Yes.
Yes, sir.
And why did we even bother to go there? Because already I told you that the minute you touch 90 degrees, you prove something that is to do with 90 degrees and you're dealing with congruence. Already in your mind, the only reason where you're going to, your final destination is right hypotenuse side. So that will help you to say, okay, already I have 2 reasons. The last one I should have is the hypotenuse because it is the right, which is 90 degrees, hypotenuse, which is this one, and the other side. The other side is the AR, which we just proved that it is common. So already we have 1, 2, 3 statements, and then we can conclude to say that triangle AQR is congruent to triangle ASR. And the reason for that is right hypotenuse side. And if these triangles are exactly the same, then it means that our AQ, which is first and second, has to be equal to first and second, which is AS, which is what they want. Then you basically say that therefore AQ is equal to AS. You leave it there. It's proven.
Is equal to AS.
Yes. Does it make sense?
Yes, sir.
Yeah.
Yes,
Always
sir.
these questions at first, they won't make sense. You won't even know where to start and stuff. But the approach is always the same. Hence, I told you this method of first and last, second and last, first and second, right? Because this just makes things easier. And if you can't label your triangles, you always use the first question, right? The first question they ask you, that 1.1.1, when they say prove that this is equal to that, use that as your hint to label your triangles in a correct way. Does it make sense? And then once you do that, there's no way you'll be lost. No way, no way. Because all you have to do from there is just to say, okay, I know that AR has to be AR. And then you just see the reason why that has to be the case. Because already from this, you can tell that they have to be equal. You go there, you just check the reason why they are equal. You write that down, right? You come to this one, you know already that AQ has to be AS, but you can't write that here because that is what you're asked to prove. Then you go to another one, you check, okay, I can prove that QR is equal to SR. What is the reason? You go back, you check. So if they mark statement and reason, maybe you don't even know the reason, you would have marks for the statement. But obviously, I don't want you to go through that route. You must know both the reason and the statement. Every time you see questions that have to do with Euclidean geometry, in Euclidean geometry, in grade 10, this is what they can trick you with, nothing more. They just trick you with funny shapes. They will bring a lot of funny shapes and stuff and ask you to prove things. I know it seems complicated at first, but follow this method. You will never go wrong, never. And then this thing, you start doing a lot of questions, right? And then it would all make sense. So I will send more questions on the group chat. And then if I send, please do them. That is the only way to be good at this thing. So going to the quadrilaterals quickly. Do you want me to tell you all the properties of the quadrilaterals we have? Because I just want you to focus on 6, right? Up until you get to metric, you focus on 6 quadrilaterals, nothing more. So I don't know if obviously you have the properties in your textbook. So it's your choice. You go to, it's your homework to go to your textbook, read all the properties of the 6 quadrilaterals, or I tell you. But if I tell you, then it means we have to have another 40 minutes of just talking about the properties of the quadrilateral.
It will be a homework.
Be a homework, man. So
Yes.
it's a holiday. Before you sleep, at least you can study 3 of them, right? And then you can do another 3 tomorrow. But by Saturday, I want you to know all the properties off by head. You must know that the square has this. Parallelogram has this, trapezium has this and this and this. That's the only way to pass this thing. If you don't, remember that in your exam, they won't say, they will just tell you only in the statement that this is a trapezium or parallelogram. Then you should know that is an answer on its own. When they say we have a parallelogram A, B, C, D, blah, 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 or they say prove that this is a parallelogram, you can't prove if you don't know what the properties of a parallelogram are. So you must know those things off by head. I will ask you randomly, or I will bring a surprise test, either one of the two.
Hi, bro.
Ask us
Hi,
randomly.
bro.
You must be ready. So thank you, I'm here. Now let's quickly do the midpoint theorem. Since we are saying that you are going to do the quadrilaterals on your own. So this is what I'm going to do. I'm going to send you problems based on quadrilaterals, and the only way you'd be able to answer those questions is if you really went through your book to check the properties. So you should submit that, let's say Wednesday, right? Because I'm giving you today and tomorrow to study the properties. But you can do that in an hour and finish everything. But surely you are tired. I understand. So the last thing that you have to know under Euclidean geometry is what we call the midpoint theorem. So the midpoint theorem, you also need it in metric. Anything that you learn in mathematics, don't forget it. Read it until you finish metric. So the midpoint theorem states that if you have a triangle, right? And then let's say this is A, this is B, and this is C, right? And you have a midpoint. You know what midpoint means, right? Midpoint means, let's say this is K, and we have a midpoint here, let's say it's L. Midpoint, if we say K is the midpoint of AB, we are basically saying that AK is equal to KB. That is what we mean by midpoint. And if we are saying L is the midpoint of AC, we are basically saying that AL is equal to LC. So what the midpoint theorem is basically saying is that if we connect these two midpoints, this line is parallel to that line. That we can see, right? That is what the midpoint theorem is saying. That's the first thing the midpoint theorem is saying. If this is a midpoint, only if it's a midpoint, if you connect those two, then they are parallel. This will be parallel to them. Then the second thing it is saying, that's the first thing it is saying. The second thing the midpoint theorem states is that KL is half the distance of BC. So meaning KL is equal to half of BC. If BC is 10, KL is going to be 5. So if you understand these two things, you understand midpoint theorem. And you know that the midpoint theorem can only apply if these 2 points are midpoint. If they don't tell you that they are midpoint, they will just indicate by this. If you know that if this is equal to this and that is equal to that, definitely these points that are here, they are midpoints. Does that make sense?
Yes, sir.
Right.
Yes, sir.
Now,
Yes.
if it makes sense, okay, and we have what we call the convex. Let's say they give you the triangle, right? But they tell you that this is equal to that, right? This side is equal to that, and then they just leave it there. And they tell you that this is parallel to that. Obviously, just by looking at this, you know that this can only be true if this is connected to two midpoints. So it would mean that that side is equal to that side. The reason would be midpoint theorem. They don't have to tell you that this side is equal to that. I hope that makes sense. So let me quickly send you something. And if you can find this one, I'll be happy. Very happy. And then after this, if this meeting ends, then we can call it a D. Unless if you want us to do functions. Or maybe we do functions another day. It's up to you, down to you. So let me quickly send this problem on the group to show you exactly how they ask these questions. You got it, right?
Yes, sir.
Yeah.
Yes. Sir.
Would you be able to approach that question? Where would you start and why? Based on everything you know that I've told you, including this new information I just told you now, let me try to draw it and see if we can do it together. These are the type of problems you'd have. Good people, if you can master these things, I'll be really, really happy. Really, really, really happy. Because a lot of people struggle with this thing, including metrics. There are a lot of metrics that don't know these things, and it's worrisome, really. It's really worrisome. Because a lot of teachers don't explain these concepts well. I don't know whether it's also difficult to them or what, but it is what it is. And when students fail, then it's as if the student doesn't start, right? Whereas the teacher didn't really do what they had to do. So that is what we have. And we are given a statement there to say that we have triangle ACE, and we are told that AB is equal to BC. So we are told that AB is equal to BC. We are told that GE is 15 centimeters. So I'll just write it here that GE is 15 centimeters. And we are told that AF is equal to FE. AF is equal to FE, which is equal to ED. Right? That is what we are told. And we are asked to determine the length of CE. So what is CE? From the information they gave us. Now, I want you to listen attentively and focus. What we see here, this every time if you have more than one triangle, you must always state which triangle you are working with. So you must really write where your focus is. So let me take this triangle out, right? I want to quickly. Do you agree that we have triangle ACE, which has BF here? And we are told that this is equal to this, and this is equal to that. What can you say about BF and CE?
BF is half of CF.
BF is half of CE, right?
BF.
What else? What else can you say about BF and CE?
AB is equal to.
No, just
They are
BF and
parallel
CE.
to each other.
parallel.
Thank you. Thank you. That is what the midpoint theorem states. That if these two lines, if this is equal to that and that is equal to that, that tells us that these are midpoints. And if we connect the midpoints, this line is going to be parallel to that one. That is what we just did now. So already we are happy, right? We are happy because we know that. So that can be our first statement to say that in triangle ACE, right? What do we have in triangle ACE? We have AB, right? Let me just come here. We have AB being equal to BC and AF being equal to CF. And the reason is given, right? They gave us that information. But from that information, we just concluded that BF, which is something they didn't give us, right? BF is going to be parallel to CE. All right, BF is going to be parallel to CE. Why are we saying so, right? We are saying BF is going to be CE and BF is going to be half of CE. And we all agree. And the reason for that is midpoint theorem. Anyone who's lost? No one. We are
So
all.
can you please re-explain?
Sorry.
Can you please re-explain?
All right. We are saying that we have AB and BC which are equal, and we have AF and FE which are equal. So if those two are equal, we know that this point is to be the midpoint, meaning the point that is cutting it in half. Mid means middle, the middle point. So the middle point is dividing these two into equal halves. And we said that though the line that is going to connect those midpoints definitely has to be parallel to this one. Why? Midpoint theorem states so. So we come here, we tell them that AB is equal to BC and AF is equal to CF. Right? No, AB is equal to BC and AF is equal to CE, not CF. What is CF? AF is equal to EF. My God. I hope I'm not confusing you. You can see that AB, BC, and AF and EF. Right? That is given. They told
Yes,
us that was the case. Right? Right? And then from there, we are done with this triangle. Would people mute yourself, please?
Can I please borrow the most?
So we have another triangle then. Which other triangle can we work with? Do you see this small triangle here?
Yes.
We have B, F,
F.
D.
D.
You agree?
Yes.
Yes. And then in the middle, we have GE. And they told us that this is equal to that. But they didn't say anything about this. Right? But check something. Check something that is very important. We proved that BF is parallel to CE. And if BF is parallel to CE, BF is this one. It's parallel to CE. This GE is part of CE. So they're parallel. That is proven. Do you agree?
So does that
Yes,
mean that
sir.
G is the midpoint
Yes, sir.
Sorry?
of C and E? Meaning that does it mean that G is the midpoint of CE?
G is the midpoint of BD, not CE. Because this has to be equal to that. It's not yet proven, but we can see it's going there because already we have the midpoint theorem. If this is parallel to this and that is equal to that, definitely this has to be equal to that. So we can't say this is the midpoint of this because we don't know what's the length of this one. But we were told that the length of GE is 15. Does it make sense?
Yes.
So what we are going to do, we are basically going to say that our focus now is on triangle DFB. And on triangle DFB, what do we know? We know that FE is equal to ED, right?
Mm.
That was given, right? It was given to us that FE is equal to ED. But we also established that BF is parallel to GE. BF is parallel to GE. And that was proven. We proved it here. We already proved that one. So then we say BG, which is this, is going to be equal to GD. We already stated that. The reason is Midpoint theorem. Why are we saying it's midpoint? If these two lines are parallel and this one is equal to that one, then it means this is a midpoint. And this, for this line to be parallel to that one, this also is to be a midpoint. So you can write midpoint theorem converse or just midpoint theorem. It's up to you. Is everyone happy so far?
Yes, sir.
Thank you.
Yes, sir.
Then if that's the case, if you are dealing with the midpoint theorem, do you agree that GE is half of PF?
Yes.
Yes.
Do you agree?
Yeah,
B is half of F.
GE is half of this. Remember that in midpoint theorem, this line is half of this one, right? So if this is half of this, we are basically saying that BF is 2 times GE. Does it make sense?
Yes.
Yes.
Okay. So we come here, we write that BF is 2 times GE. Because if GE is half of BF, then means BF is 2 times GE. Okay, Tavan, where are you going with this? They told us that GE is how many centimeters? 15.
15. So when you
Yes.
times 15 and 2 is going to give us the length of
30.
which is the length of CG.
So BF is equals to 30 centimeters. Is this what we want? No. They said they want CE, but we found BF. What do we know about BF from this triangle? What do we know about BF from this triangle? It is parallel to?
Parallel to G.
Parallel to C.
Yes. And if it's parallel to CE, it means BF is half of?
CE.
And if BF is half of CE, then it basically means that CE is 2 times
To
CE
BE.
is 2 times BF. Do you agree?
Yes, sir.
Thank you. And we know that BF is 30 centimeters. So it means you're going to say 2 multiplied by 30. So our CE is actually 60 centimeters. Does it make sense? This is what I would advise you
Yes,
to do.
sir.
Don't look at your corrections. Try to do the whole thing by yourself and see where you go. If you don't understand something, let me know. So that will be the end of our meeting, because I really want you to go do quadrilaterals so that I can send you more problems. Now, all we do is do problems, a lot of problems, right? And then we go to functions. So did I lose anyone elsewhere, or is there anything that you don't understand ever since we studied Euclidean, since from Saturday up until tonight?
I understand everything.
No questions.
No questions.
So as soon as you are done with quadrilaterals, hit me up. Then if one person hits me up, you'll see when I send questions on the group, right? And then I will tell you when is it that we'll do corrections and everything. Is that okay with everyone?
Yes,
Yes, sir.
Right. Don't sleep. If you're tired, rest nyana, eat something, and then go back to your books, please. Thank you for attending.
Thank you.
Thank you for
Bye.
attending.